Crackdown, the physics of. Alright, let's take a look at this game Crackdown. It's a game full of cool explosions. Nice scenery. Cool cars. But there's some things that just outright baffle me. Like, what's that? What are those things? What are they doing? How are they doing this? Why? I am totally confused. And despite the fact that that guy right there, the one driving, he probably just caused about $300 worth of damage, but is still able to do things like this. How do you climb a wall with an SUV? Seriously, that's not possible. I'm totally confused right now. What's going on? Alright, so let's take a look at this guy. He defends the city from bad guys and gangs, things like that. You know what? Beats him up, looks good, and you know what? He can have a little fun, because that's totally cool. In fact, you know what? It's groovy. Alright, so let's take a look at what he's able to do here. He's able to jump up an entire building just like that. Boom! Alright, wait, let's count the windows here. 1, 2, 3, 4, 5, 6. He's able to jump up a 72-foot story building. Oh my gosh. Alright, so you know what? 72 feet, we need to add one more because of the roof height. So, 84 feet in total, 25.6 meters. Alright, we need to find the force before we find the work. Therefore, he weighs about 99.8 kilograms, which is 978 newtons. Multiplied by the height, we get 25,000 joules. Alright, new scene! Alright, look at those cars, look at them go! You know what? Those cars are going so high, you attach wing to them, they're a new Class 1 aircraft. Those things take so much energy to do that, don't they? They're going about 75 miles per hour, but you know what? That's crazy. So let's take a look at this scene again. Alright, those things can just clear some serious distance. Just look at that and ignore the rockets. Alright, so this is totally confusing me again. How are they able to do this? Well, you know what? We need to find the distance because I'm totally curious on that. Alright, so we need to find it with these numbers right here. Boom. Alright, find it using that equation. Using that, we get about 444 meters. But hold on a minute. Isn't 444 meters about, I don't know, about a third of a mile? It's almost a third of a mile. But this seems a little weird. That right there doesn't really look like a third of a mile. It looks like less than that, or something. It doesn't look like a third of a mile, but something's wrong. So you know what? Initial velocity was just estimated. It was used in an approximation, and time, not really a changeable variable, but the only variable left is acceleration, so the gravity has to be different. Find the new acceleration. Alright, we're going to approximate 350 meters, because that's what it really looks like. So, you know what? We get this equation here. Boom. This equation, and then we finally get an answer of 5.6 meters per second squared. New number, eh? Which is approximately half of Mercury or Mars' actual gravity. So, this doesn't really look very difficult now, does it? It looks like any person can really do it. So, we need to fix this thing up, see what it actually is. So we get about 560 newtons. Oh, yeah. Now we need to find the work. Alright, so we get about 14,000 joules. That doesn't seem as hard as 25,000 joules. And new topic. Alright, so we're driving along. Look at this guy go. He's got a real nice car, big engine. Looks like he has the road to himself. I mean, how fast can this guy really go? Let's take a look here. Alright, so he's about 200 miles per hour, if you can't read that down there in the bottom right. And, well, he's bumping into roads, I don't know, or the things, I don't know. But he isn't paying very much attention. So, he's about 300 miles per hour now. If you can't really read that, that's about 350, 360, 370, 380, 390. He's almost about 400 miles per hour right now. This car is crazy. Alright, so he's driving, and bam! Alright, so he hit from 0 to 400 miles per hour, hit a pole in less than a second. Work it out. Let's find out how much energy was actually behind that thing. But it's an inelastic collision. Well, not in this game. In this game, it's an elastic collision. Therefore, we're using this equation with these numbers. Therefore, we're getting numbers like this, and a pirate's involved. But this makes no sense. That number doesn't equal 0. Well, you know what? I'm just going to say, because this game is totally confusing me, that we're just going to leave this subject alone. I'm not even going to go into this. So, I'm backing off this thing here. I'm not going to do this anymore. So, you know what? I'm done for today. You know what? Okay, tune in next time to find out why the chicken made you think it crossed the road when it didn't. I'll see you guys later.